अच्छा, अस्सलाम वालेकुम, बिस्मिल्लाहिर्रहमानिर्रहीम. Today the discussion of topic is again the continuation of the nature of function. And in nature of function we started the debate related to the quasi-concave and quasi-convex function. And finally we concluded that the quasi-concave and the quasi-convex function, these are some important properties to prove the nature of functions. And why we assume that quasi-concave and the quasi-convex function, it is there are some important axiom related to these functions, that these are some weaker notations to prove the nature of function. When we talk about the concave function or convex function, it means that we are talking in the sense of very strict nature of functions, के functions should be strictly concave or strictly convex. ठीक है, क्योंकि we talk about that कि sometime we have increasing returns to scale initially, we have decreasing returns to scale, or the constant return to scale we cannot predict during the nature of production or at the time of utility function and whatever. Clear? So that's why we have to be relax our assumption कि our function is quasi concave or quasi convex, because quasi every concave function will be a quasi concave, and similarly every convex function will be a quasi convex. We have proved in previous class. But in case of the vice versa, if we assume that if your function is quasi concave, so it must be initially a concave. It is not necessary proof. Clear? It may be concave, it may be convex, it may be linear. We have proved in previous lecture, right? So, and now today we will take some numeric or some example of the Cobb-Douglas function and the log function, and how you can prove that they are quasi-concave or quasi-convex. What are the nature or what are the fundamental axioms and assumption of these functions? Clear? So, first of all, some important conditions. Some important condition. Now there is some concept of composite function or compound function, you can say that. Compound function. How you can write this compound function? We can write it, let's say, f of gx. Sometime we can write it for in some book, f of g. And what about that function? It means that x will be a domain of gx. X is domain of g. Okay? And we can write y equal to, for example, gx, or z equal to gx. So y will be the range of that function. It will be the range of that function. Range function of gx. Okay? And ultimately, range of this function will be a domain of function f. Am I right? Range of this function will be the domain of function f. Clear? So it means y will be domain of function f. We don't know what is the nature of function is f, okay, but we know that it is kind of the composite function. Let f is a function of another function, and that function's g depends on x. Clear? Function in term of function, right? So we are focusing here what should be the nature of gx, and then we will define nature of function f as well. To prove the function is quasi-concave or quasi-convex. Why we are going to define this one? Sometime you take the example of the log function. Clear? And sometime you take the example of Cobb-Douglas exponential function in macroeconomics and in microeconomics theory. Clear? So it means when we write this one, what does it mean? It is kind of the composite function. Why? Exponential is another nature of function, and that it depends on, for example, another kind of function. And here, this is, let's say it is a linear function. Okay, x kind of the linear function, or you can write this one. Okay, x is generally gx. Clear? So what does it means? We are taking a exponential of function gx. How? Take the example, let's say हम sometime we represent that कि y equal to x alpha, sorry, L alpha and k beta. It is kind of the Cobb-Douglas function, very commonly used. Clear? And sometime you have to take a log of this function. You have already discussed about the concept of, for example, econometrics. Clear? And in case of econometrics, you have to take a log of functions to find out the growth of any value. करते हो आप लोग? Clear? You take a log of that function, and log represent the percentage change in that value. It is the nature of log. Clear? And why? कि भाई, for example, why we take log of that function? Let's say कि भाई मैंने कहा कि भाई it is, for example, GDP in term of growth, sake of understanding. Clear? And we are taking growth of GDP. So ultimately we try to define all other variables which are our explanatory variable. They should be in the form of growth or percentage change. Clear? To make the same scale of that variables. यही करते हो? तो हम क्या करते हैं? Then we take the log of these functions to define in term of percentage or growth. Clear? Through EViews, SPS and so on, or Excel. Clear? Technically it is wrong कि one variable you are going to take in values of $100 or $1,000, and other variables you are taken in term of growth or log or in term of the percentage. So technically it is wrong. सही है? तो you have to make the at the same level of scale to take all the variables. हम ये करते हैं. ठीक है? It is basic mistake normally student do not know about in what will be the nature of or the how to define the variables in the form of the functions हमने किस तरह define करने हैं। अब मैं इसका log लेता हूं let's say तो क्या होगा ln y taking log both side clear so it means के this is ln L plus it is the basic formula and beta ln k am I right clear इसी तरह डिफाइंड होगा कि आपके पास लॉग लेंगे इसके ऊपर अप्लाई होगा लॉग अल्फा यानी लॉग एल प्लस लॉग बीटा एंड देन यू कैन यानी पावर को आप नीचे उतार सकते हो तो इट विल बी लाइक sorry alpha ln so on plus beta ln k clear so that is called the log linearization of the function clear बिल्कुल अब नाउ हमने कहा कि भाई दैट फंक्शन वी डोंट नो कि व्हाट इज द नेचर ऑफ दैट फंक्शन हम ये कह रहे हैं कि भाई इफ this function clear for example is convex clear so what will be the nature of finally ln after taking the log or another way to define the function sometime we transform the function how you transform the function you take the log or something else it is basically in term of microeconomics theory is called the monotonic transformation of the function and it is basic property of the indifference curve or the consumer preferences that your functions or the utility function is monotonically transforms towards another functions that marginal rate of substitution should be constant and you transform that function in that way that marginal rate of substitution should not be changed clear अब for example ये हमने कहा कि it is one IC and this is another IC right ultimately the level of utility will be less than as compared to this one यही होगा clear and this is kind of the monotonic transformation if we are here and consume x bundle of choices and we transform that a function to consume another bundle of choices x bar but the rate of substitution nature of rate of substitution between these two variables what are here x1 and x2 x or y whatever clear it is keep constant why the behavior of consumer choices does not change and it is still same along this indifference curve am I right
Yes.
clear क्या होगा whatever the rate of substitution MRS along this IC it will be different here but that should be same on that point of indifference curve same होगा you can check by plotting a tangent या tangent plot की ये tangent plot करी both have the same rate of change clear and similarly you can say that there is the same rate of change clear and you can take another points downside the same rate of change but if the curvature of IC is going to be changed let's say this one clear so it means preference behavior after transformation of utility function how you know that because there is the low level of utility and we have the high level of utility as per the definition of the indifference curve when we move upward side so but the nature of function is going to be changed here why because the nature of preference is not same like this one So how you can check that? Because the marginal rate of substitution is not going to be same along both indifference curve. So it means that transformation of function is very important. Final conclusion is that, but that should be the monotonic transformation. Clear? Not something else.
ये दोनों में एक ही जैसा रहना चाहिए.
Monotonic transformation means that we assume that the function is going to be transformed in the way that it will be a monotonic transformation of the previous function.
मोनोटोनिक ट्रांसफॉर्मेशन जब होगी जब दोनों में जगह अगर हम
MRS keeps same.
MRS same.
Exactly.
वो मोनोटोनिक
Monotonic transformation है.
ठीक.
अब now, what are the ways to monotonic transform the function? It is important thing that we are going to focus here now. Clear? Okay. Up. Number one condition, for example, f and gx is cosine concave if and only if gx is concave and second condition, okay. Okay. Here are some important things. First of all, f of gx is, it is kind of any composite function or is cosine concave if and only if gx is cosine concave, and f of gx, f is strictly increasing function. Similarly, the case of cosine concave, So f should be strictly increasing function. Now x is strictly increasing function. So what is the function of f, or what should be the nature of function f? So it means there are two choices we have in term of composite function for economics, is that either we have to take a log of function, ln of function, or we have to take a exponential of function. Why? Exponential is always increasing function, clear? And similarly, ln is always increasing function. Ln does not change the nature of function, and exponential and ln we can prove here. How? रब कर दूं इसको? Okay. For example, z is a x alpha y beta. Take ln z. So ln a y beta. So we can define ln a plus, similarly alpha ln x plus beta ln y, right? What will be the function of the value of, or the nature of ln x will be increasing? Clear? Will be ln x increasing.
Yes.
You can put the values and check and draw the function. Similarly, the ln y will be increasing. So these are the increasing function. Subject to the value of base of ln. Clear? Subject to the value of base of ln. And ln should be greater than 1. Clear? If the ln is greater than 1, so you will have increasing function. Ln greater than 1. Clear? Right? So you will have this kind of the function. Okay. So what does it means? To make it linear. Okay. So we transform through the ln. Am I right? It is common practice which we do in case of any research and something else. We take the log of the function. So this is ln x plus ln y. So it means these are increasing function. We are not talking about कि either they are increase with decreasing rate and something else. They are increasing function. Clear? Okay. And what about this one? Increasing function, and ultimately, if we assume that K, these are concave in nature. Clear? Concave in nature because it is going to be increase, right? So what does it means? K, these are concave in nature. Okay. So sum of concave function, these are ln x plus ln y, which we have discussed in case of the property of the concave function. Property is here, concave plus concave
remains concave.
remain concave. Clear? So it means that it will be a concave. So when we have a function is concave, सही है, and it is transformed with any increasing function. Why? Can we transform with increasing function of ln z? Clear? So it will not the change the nature of function. So function must be quasi concave if initially it is concave. We have proved previously. Clear? बिल्कुल. Vice versa, it's not possible, but if it is initially concave, so it will be quasi concave. Clear? So we have discussed. So ln z is increasing transformation of concave function. That's why function is quasi concave. It is same like for concave, convex. Clear? Okay, take another example. Okay, z equals to exponential की power x square. Okay.
ये नेक्स्ट एग्जांपल है ना.
Next example. Yes. It is kind of the quadratic function because I can write this k g of x is minus x square. It is kind of the quadratic function. And what will be the shape of that quadratic functions? Recall the concept of parabola, hyperbola. Clear? Exactly. So if this value is
Negative.
minus 1, clear? So that function will be open down. Clear? Because it is a less than 1. And vice versa, if you have g of x is x square a greater than 1, so you will have it will be open up. So it is concave and this one is convex. Ln z equals to, sorry, and E is strictly increasing by nature, same like ln. So z of f of gx, this is f and this is gx. Clear? So if the function is concave, so ultimately after the exponential or transformation through exponential, it must be a cosine concave. Clear? Because it will not change the nature of function. Or you can have the, let's say कि अगर z equals to e of x square. Clear? So it is convex. So it means कि it will be a cosine convex. ठीक है? So it will be a cosine convex because x square or g of x is convex and E is strictly increasing function. E is strictly increasing function. Clear? So अब देखो, it is very common practice. Theoretically we do not know कि why we are going to take a log or exponential of the functions in different econometrics technique and something else, and we apply these concept. So these are some theoretical understanding or the definitions कि why we take the exponent of the functions or the log of functions. Because and a strict assumption is that ln should be greater than 1. It should not be less than 1. Otherwise, it will change the nature of functions. Clear? So now take another example. Let's say f of xy, it is ln x a y b. So this is a ln x plus b ln y. Okay, so these are increasing increasing and concave, increasing and concave. Clear? Right? So ln transformation is strictly increasing, ln is strictly increasing. Well, not so. Nature of functions will be same. Same. Right? Okay. Now another important topic is existence of utility function. Okay. We have decided what should be the nature of function. Just I recall you we proved that the function should be cosi concave or cosi convex, depends on the objective of the optimization is here. Clear? And cosi concave and the cosi convex are the weaker conditions or assumptions to assume the nature of functions. That's why we assume that these are the cosi convex or cosi concave, because initial nature of function we do not know what is. Either the function increase with increasing rate, increase with decreasing rate, increase with constant rate, we do not know. That's why we relax our assumptions, because it is common practice or naturally in case of production, it is not necessary we start your production to always you have a return from your initial state increase with constant rate. And similarly, it is not possible your initial stage of production provide the return with decreasing rate or it is increasing rate. Clear? So we don't know. There are all possibilities there. So that's why we have to relax. But why we assume that finally the objective is to optimization or to find out the global maxima, because in case of the global maxima we need a unique answer, so there should be the highest value of the function. That's why finally you have to assume it should be the cosi concave. Clear? And same case of cosi convex here. So that's why in books they use the concept of cosi concave and cosi convex in microeconomics theory. Clear? So and we discuss some nature of functions. तुम लोगों ने अप्लाई भी किया होगा. This kind of the functions you will apply in case of the macroeconomic theory. Exponential nature of function you will discuss. आपने यानी you had discussed in advanced macroeconomic theory, and similarly the linearization of the function you have discussed.